Tessellations of the plane. Another way to word this is tiling of a floor. When you tile a floor, flat surface, you're tessellating a plane. A tessellation of a plane is the filling of the plane with repetitions of congruent figures in such a way that no figures overlap and there are no gaps. Here are some tessellations. This one's a tessellation with equilateral triangles. This one's a tessellation with regular hexagons. And this is a tessellation with irregular pentagons. Notice that regular polygons and irregular polygons can tessellate a plane. Notice that in each case, there are no gaps or overlaps. So what is the requirement so that a polygon can tessellate a plane? What is the requirement such that if you put polygons next to each other, there will be no overlaps or gaps? The requirement is that if you put polygons next to each other and you don't want gaps or overlaps, then if you add the individual angles about this vertex, this point is called the vertex. If you add these angles, they should add up exactly to 360 degrees. For the tessellation to be possible, the sum of the angles about each vertex should be exactly 360 degrees. Therefore, tessellating a plane with regular polygons can only be done with equilateral triangles, squares, and regular hexagons. So you're going to use regular polygons. You could only tessellate, or tile if you like, with equilateral triangles, squares, or regular hexagons. Notice the pentagon was not mentioned. Let's find out why. Can a regular pentagon tessellate a plane? These are the steps. First, find the sum of the interior angles. This is the formula for finding the sum of the inside angles, the angles inside the polygon. N represents the number of sides of the polygon you're considering. In this case, we're asking about a pentagon. It has 5 sides, so N would be equal 5. So replace the N with a 5. 5 minus 2 is 3. 3 times 180 is 540 degrees. In other words, take a regular pentagon, add the measure of the inside angles, the interior angles, and they should add up to 540 degrees. Now, since it's a regular pentagon, since it's regular, all the angles on the inside should be congruent to each other. So find the measure of each interior angle by dividing 540 degrees amongst 5 angles. This tells us that each of the interior angles is 108 degrees. So here's the pentagon, the regular pentagon, and each of the interior angles is 108 degrees. Now imagine you were going to tessellate this plane. That means you would put pentagons all around. So just take one of these vertices. So there would be a pentagon here, and take this vertex. If I'm able to do it, I should be able to add the angles, the individual angles of each of the pentagons. So there would be one right here, one here, one here, or maybe 2 here. You would have to draw it. But regardless, the angles should add up to 360 degrees. So now we could ask ourselves the question, can I divide 360 degrees by 108 degrees? And this is what we get. We get 3.333 repeating. So we don't get exactly 3. So no, we cannot divide 360 degrees by 108 degrees evenly. Therefore, a regular pentagon cannot tessellate a plane.